Okay. My name is Morgane Amelot, and I've been working on killer whales depredation in the south of the Indian Ocean. First of all, I would like to introduce one of the basic concepts I worked on, which is human-wildlife conflict. Human-wildlife conflict are any kind of conflict resulting from competition between the needs of humans and the needs of wildlife. It causes different costs, which are ecological, could be social or economical. To give you an example, this is the case of big carnivore in Africa predating on livestock. Depredation in fisheries is one kind of human-wildlife conflict, and it is a growing problem. It is a growing problem because Longline fishery, which is the most susceptible fishery to depredation, sensitive fishery to depredation, is a growing industry since 30 years. It took place in some region instead of other fisheries, which are like bottom trawling, because they have less ecosystemic impact and less destructive impacts. This is impacted by depredation because, as you can see on the picture, the prey is fully exposed during the hauling time to other predators. We define depredation as the removal of part or the entire prey from one fishing gear by other predators than human. Most of the time, it's marine mammals and sharks showing this kind of behavior. I've been focusing on the south of the Indian Ocean situation, and more specifically on Crozet and Amsterdam and Saint Paul Islands. It is French territory from some Antarctica area, and they are very interesting for several reasons. They are interesting in an economical point of view for France because they have both high commercial value fisheries. The Patagonian toothfish fishery is now for France one of the main fisheries of high economical value. In Amsterdam and Saint Paul, the main fishery is the lobster fishery. However, they are also fishing 5 other species of fish, including the blue-eyed traveler, which is also high economical value fish. But this is mainly interesting because it is a place with one of the most important depredation rates all around the south of Indian Ocean. Depredation in this area, and in Crozet area more specifically, caused an estimated loss of 28 million euro between 2003 and 2012, caused by killer whales depredation and sperm whales depredation around this area. This being estimated based on the comparison between the cage per unit effort without depredation and with depredation in this area. It is also one of the places with the most important rate of fishing days with presence of depredating individuals around the vessels. It is 50% of the fishing days in Crozet area with depredation and 58.4% in Amsterdam and Saint Paul, which represent half of the fishing day with depredation along the year. But it also has ecological impacts on killer whales and not only economical impacts. Indeed, during the 90s, there were a lot of illegal, unregulated and unreported fisheries in this area. And the estimation of the reduction of the killer whales abundance due to interaction with illegal fishery at this time was of 60%. Basically, illegal fishery was just throwing dynamites in the water when killer whales were present around the vessels. But there is some lack in the information to estimate the precise cost of depredation in this area. This is about how many individuals are involved in this behavior, but also what are the abundance trends of these depredating groups. Are they still growing? Are they staying stable? Is this depredation behavior going to evolve? And how it is going to evolve depending on the abundance in this area. So the aims of my study were to estimate the number of depredating killer whales in Crozet and Amsterdam area. In the Amsterdam area, it's never been done before. And in Crozet, I was working for the first time with the D form of killer whales. To assess the long-term trends in this number, and finally to assess if depredation intensity and frequency, so when there were depredation, if there were more individuals present around the vessel, and if the number of days of depredation were increasing also with the time, was dependent of this number of individuals in the population. So for that, I use photo ID methods. So there is fishery observer on board on every French vessel in these areas. They're taking pictures every time they're seeing killer whales around the vessels. Based on that, we did a photo ID work to identify all the individuals year by year and month by month. To each individuals, we give a personal ID corresponding to the groups they were part of. So CR is Crozet regular, CD is Crozet form D, the one that you can see on the picture A, and AM is the Amsterdam form. The Amsterdam form and the Crozet regular form are pretty much the same. They're looking the same. It's this big eye patch that you can see on the picture B. And the Crozet form D, you can see a very big difference, morphological difference. So we're also associating the ecotype because of that. Then we're also associating a yearly marking level depending on the number of notch and the difficulty to determine which individuals it was. We were also determining the quality of the best picture available for each individuals, and then the stature of the individuals, either newborn, juvenile, or adult, based on ecological information. With that, I designed the microcapture matrices, 3 actually, 1 per group. It was an open population because I had more than 10 years of study, so open to death and to birth. But we also observed in the preliminary analysis that there were temporary migration with other than I was not working with. So I had to work with a robust design models to be able to assess the temporary migration. I chose then to work with Huggins robust design models because they're able to deal with individual heterogeneity in capture probability, which means that I was able to introduce the quality and the level of marking as something impacting the probability of capture of each individuals. And then I was determining the depredation intensity and frequency. So the depredation frequency was the number of sets. In Longlines, they're all in different sets in the water with a lot of hooks on them. When they're holding them, they're observing the depredation. So I was doing the ratio of the number of sets with depredation per year over the total number of sets per year. And then the number of depredating individuals per set per year, which means the number of individuals we're able to identify per set. I tested first that the effort wasn't a factor having an impact on this number of individuals identified. About the results, my first results, my preliminary results were about recruitment dynamics, and it was just based on the identification process, the photo ID process. So you can see on the different graph, the 3 different groups, Crozet regular, Crozet form G, and Amsterdam regular. The yellow bars are the effort per year, and then the 2 lines are the cumulative number of new individuals per year. The one from the bottom is the one for the adults, and the one on the top is the one for the total population. So what you can see is that the one for the adults is stabilizing after a while, and this could potentially indicate a change in the recruitment dynamic, which means that we're not having new adult individuals that we're seeing at this time. This potentially means that the only new individuals we have are juveniles or newborn that are already part of the depredating group because they're growing in this depredating group, but not joining from other group outside of the study, the area of study. And it's also potentially give us information on the learning process when we have this fast increase at the very beginning of the new adult individuals coming them. But this question of stabilization also asks us questions about the competition, intraspecific competition of killer whales in depredation. These are the results of my best Huggins robust design models, abundance estimations. I based my selection on the IKK criterion, information criterion. You can see on the one on the left, the Crozet regular group. The one on the left in yellow are the Crozet D group, and the one on the right is the Amsterdam one. The one on the left, as you can see, there is also this fast increase at the beginning, and then a stabilization. I tested the trends of these different groups. We're using linear and nonlinear models. Finally, the best model I obtained for the trends was a logistic models with indeed a stabilization. I had for the 2 of them a significant p-value with less than 0.001. For Amsterdam, we were just able to do estimation every 2 years because the data were missing, because it's not the main fishery, so fisheries observers are less involved in the data collection. And you can see this low number at the end. It is just caused because by the fact that we didn't receive all the data when I left of 2018. The observation we can do about this abundance are very interesting to lead to an ecosystemic-based approach of the fisheries in this area. Now that we know how many individuals are present and done, we can determine the biomass of fish allowed to each individual, and being able to determine what are the part of the fish taken by killer whales during depredation events. This is interesting because since last year, we didn't knew what was the natural diet of the killer whales in this area. Then isotope tests were done on these populations, and they've seen that Patagonian toothfish is already part of their natural diet. However, killer whales are not supposed to dive that deep in natural behavior state. They're diving deeper when they are diving during depredation behavior. And the thing is, Patagonian toothfish have a stratification, colon water stratification. The juvenile are shallower than the adults, which means that killer whales are potentially feeding on bigger Patagonian toothfish when they're depredating than the one they're supposed to be feeding on in a natural behavior time, which didn't cause a switch in type of prey, but it's a switch in species of prey, but a switch in the stage of the prey they're feeding on, which could also have impact on the fish stock. There is also potential impact on other preys. These killer whales, the regular type of killer whales, is a generalist species feeding on other marine mammals in this area. So the fact that one easy resource is available in this area could also reduce the predation on other resources. This is important to determine realistic quotas for fishery, taking into account this new predation being there. This is also important to potentially define fish quotas allowed to killer whales to be able to manage this killer whales population and to not impact them if there is a collapse of the fishery. This also impacts the possible mitigation measures. Indeed, there is, it means this number of killer whales means that there is more than 6 killer whales for 1,000 square kilometers in Crozet area and more than 13 killer whales for 1,000 square kilometers in Amsterdam in Saint Paul. Killer whales are able to detect fishing vessels more than 100 kilometers away. So if one fishing vessel is entering the dune, potentially all the killer whales could detect it, which make this fishery way more difficult for fishermen to do. Finally, about the frequency and the intensity. I found that the frequency of depredation was staying almost stable during the entire time of study, varying between 30% and 50% of set. This value is different from the first one because I'm talking of set and not of fishing days. I tested it, there were no trends in these values, but the number of depredating individuals per set was increasing along the time. This potentially means that there is an increase of the competition. Killer whales are not present more often, but they're more when they're present. And this increase of competition could also lead to a spreading of this behavior. Indeed, if killer whales don't find the resources anymore in this area, they could totally migrate it because they're able to migrate that far in adjacent water, such as the Kerguelen Dune, which is pretty close, and is the main fishing ground for Patagonian toothfish, which could also have impact on the fishery. In conclusion, there is different impact of depredation. These impacts could be ecological, directly on killer whales, with positive impact on the reproductive output and longevity of killer whales by having this easy resource, but also negative impact with illegal, unregulated, and unreported fishery that is monitoring in the economical dune, but not always in the international water surrounding it, and killer whales don't really make the difference. And increasing the dependence of killer whales to this behavior. It could also have ecosystemic costs with fish stock modifications, economical cost with an increase of the amount of fish lost during depredation, and the cost of implementing mitigation strategies, and then social costs that are also very important, with an increase of the time spent offshore by fishermen to fill their quotas, but also an increase of time spent in mitigation measures application, which are impacts on the potential acceptance of fishermen of working on new mitigation measures in the future. This study is very interesting because the high rates could give us an example to also work on depredation all around this area. That is a really broad problem in the Chilean water, British water, Australian water, and South African water surrounding these islands. These are my references, and I really want to thank you for listening.